trust me, I used the same implementation for every language. The performances that you are seeing now are the performance with Dart, 21 FPS. Then we can switch to Rust. It's a huge improvement in performances, okay? For people that love C, you are going to see a few less FPS, okay? And then there's the fourth language that gives you nearly the same performances as C and Rust. Which language do you think it is? I heard Kotlin. No, it's not Kotlin. No, it's not JavaScript.
Assembly?
No, I'm not that crazy, okay? No, it's not Elixir. It's not OCaml, it's not Haskell, it's not PHP. This is Dart. Again. Okay? But why? Okay, so hi everyone. I'm Matteo Maria. I'm a Flutter developer. As you can see here, he is me. And that beautiful guy is Marco Bavagnoli. He helped me a lot to research for those slides and also to create the demo that we are going to see later. And today I'm going to talk to you about Dart FFI. And let's start with talking about what is FFI. FFI is a mechanism that helps you to, that lets you to make two programming languages talk to each other and call the functions that you wrote in one with the other language. And these are basically the whole flow to achieve that. And today we are going to look to every step of that flow and during the presentation. So why should we use FFI in our Flutter apps? Few things that I thought about were like pre-existing libraries. So for example, OpenCV, there's no need to recreate it in Dart. And so why just don't we use the C version of that library? Same thing for file encryption libraries or FFmpeg and so on. And also, of course, for performance. Which platform are supported? So where can we use FFI? Every platform, so mobile and desktop, and with the exception for web, which doesn't support FFI out of the box. But in order to use FFI on web, we need first to compile for WASM and then use the JS that is provided after the compilation and use it with the JS interop library that is provided on pop.dev. So, what we are going to see today. I've created a small demo, which is a simulation of bodies and particles that spin one around the other. And as you can see, I used Dart, Rust, C++, and a secret language. Okay? And we are going to make a comparison of FPS. Actually, this is not the amount of FPS we are going to see today because in that screenshot I used a higher amount of particles. Those were like 5,000, and in the code that I have now there are 3,000, so the number will be higher. But yeah, that's the demo that we're going to see later. I ask you to start to think about the fourth language that I used there, and later we'll see what it was. So, let's start. as the first thing, we are going to create our project. So we create our Flutter app. And then we add the FFI gen package. That package is really useful because it lets you translate your C code into your Dart code in order to call the C functions from your Flutter app. And after that, we are going to create our C plugin. We don't actually need to create a plugin for that. You can just dump all your code inside your main folder of your project. But I wanted to create those plugins just to be more, to tidy up everything, okay? To be more organized. So I created a folder named plugins. Then inside that folder, I ran that command. As you can see there's the platform flag. You can list all the platforms that you want to support. And then there's the template flag, which is a flag that lets you generate files from a pre-existing template. And that one is available through the Flutter CLI and generates for you example code for C and all the files that you need to then build your code. So what we get from running that command? We have a source folder which has inside a C file. Inside that C file we can see two functions that just do a sum of two numbers, okay? A .h file, which is just the header file for those two sum functions, okay? And a CMake list file, which is used to tell the compiler how to compile our C code. We can also find a FFI gen.yaml file that is generated with the FFI plugin flag. And inside that file, what we can find? There are those two lines, which are the entry points where the FFI gen plugin can find our header file to translate the C code into Dart, okay? So here's the path that brings to our header file. And then, when running that command, we can generate the Dart code that translates C into Dart. As you can see, those are the two files that we get from running that command. This is the translated version. Can you read this? Okay, perfect. This is the translated version of the two functions that we see earlier. As you can see, there are these weird types like FFI.pointer of T. And this is just how FFI translates the types from C to Dart. And then there's another file, which is the one that is actually going to be visible from our Flutter app that brings another level of abstraction to those two sum functions, okay? And also, as we can see here, there's a bunch of declarations for different platforms because every platform needs a different type of library in order to read that code. So, for example, for Linux and Android, we have a .so library. For Windows, there's DLL. And for macOS and iOS, there's the dynamic library. So we have to tell the app which file to load. Then, after generating all those files, we just go to our pubspec.yaml file, the one that is inside the main folder for our Flutter app, and we add our plugin, just as every other package from pub.dev, with the exception that we are not going to provide a version because it's not hosted, but we provide the path. I don't know if you can read it. Okay. maybe I go here, the path to our folder, okay? And we are good to go. After that, we can just create inside our app a small example. So I imported our plugin as every other package. And then inside the main view, I added a button with a set state. And that's all. That's some function with 5 and 3. It's just the function that we defined in C. And that is just mapped through FFI gen to Dart. And then we use it as like every other function. And as you can see, here's the actual example. And it works smoothly. So let's go. So now, what if you want to integrate a language different from C? As I mentioned before, I used Rust, okay? So what's the process to use Rust? Sorry. I ran the same exact command as earlier, but this time, inside the source folder, I'm going to run the cargo new command because because C is directly usable, okay, and instead Rust is not usable out of the box, so we need to create by our own the project, okay. So we need to run that command with the lib flag, so it's not going to have a binary that needs to be compiled or run, but it's just a library, and he knows that we're going to create a library. And also, inside the cargo.toml, for people that don't know how Rust works, the toml file, it's exactly like the YAML file for Flutter, so you store there the information for the project and for the building. And under the lib section, we are going to add that line, which is going to tell cargo to create a C dynamic library, okay, after compilation. So if we go in the source folder of our Rust project, okay, not the one that we got from the Flutter plugin, we can see a lib.rs file. Inside of that, there's just another sum function as an example. I just did a few modifications just to align the code with the other one. So I added that pub extern C. It's needed to transform that function and export it as a C function. And also that nomangle decorator that is used to tell the compiler to don't remove our function, because during compilation unused functions get deleted to improve performances, and obviously our library is not used at the time, so our sum function is going to be deleted. With that decorator, we're going to tell the compiler, no, leave it there, we are going to use it later. And then I just rename it to align our code to the C code that we had before. Then, inside our CMake lists file, which is used for compilation, we are just going to add the cargo build release command, and we are going to say where to find the compiled library to use it later, okay? Then, just like we did with the C plugin, we are going to add it as a dependency of our project, and then we are good to go. I just commented the import for the C version, and I added the import for the Rust version. As you can see, it works smoothly, okay? So that works too, okay? Everything good, unless you use macOS. Because C has no problem with that. But for other languages, I only tried with Rust, but I think that there's a problem with all other languages different from C. You need to do an extra step for macOS and iOS. So what we need to do? We need to build the library manually, okay? And then we need to go inside the building folder and take our library, okay? This is the library compiled, dynamic library. This is a specific format that macOS and iOS want. In the case of Linux and Windows, you are going to see an SO file, and you don't need to do anything with those files. But for macOS and iOS, you need to take that file, then go inside the macOS folder of your Flutter project app, open the XC workspace file, then after like 10 minutes, Xcode is going to open, and then under the runner section of that inside Xcode, you are going to see the framework section, and here you need to add your library manually, okay? So we need to do the add file, to choose the add file, and then link that file that I showed you earlier. Then, inside Xcode, we need to bring that file to the bundled frameworks section of the project. Then we need to add that again to the copy bundle resources. Then we need to mark it as optional and not required under the link library with the libraries, binary, sorry, with the libraries. And then we need to add it under the copy bundles resources, okay? So, I mean, that's the final state of our Xcode project. And after that, it works, okay. And so, I'm going to show you the live demo now. I hope that everything is going to work smoothly. Okay. Oh, while it is running, just a disclaimer, the code is crap, okay? Terrible, okay? But is the worst code you're going to see in every platform, so in every language. So it's bad in C, it's bad in Rust, it's bad in Dart, and also you have to trust me. I used the same implementation for every language. It is exactly the same code, okay? And so the performances that you are seeing now are the performance with Dart, okay? As you can see, 21 FPS. There are 3,000 particles that are flying around, okay? Then we can switch to Rust. As you can see, it's a huge improvement in performances, okay? For people that love C, it's actually C++, but you're going to see a few less FPS, okay? Don't ask me why. I know nothing about low-level programming, so don't ask to me. And then there's the fourth language that gives you nearly the same performances as C and Rust. And what do you think? Which language do you think it is?
Java.
What?
Java.
No. No. I heard Kotlin. No, it's not Kotlin. No, it's not JavaScript. What? One at a time. I can't hear you.
Assembly?
No, I'm not that crazy. Okay. No. Okay. Just one more. No, Python. We'll talk about it later. You can't use Python. with FFI. Let's talk about it now. Why you can't use Python? Because you can't compile Python to a library. If you use something like Cython, then you can compile it as a library, but Python is interpreted, so you can't get a library as an output. And then you can't load it inside your app. Okay? Perfect. So, no, it's not Golang. What? No, it's not Elixir. It's not OCaml, it's not Haskell. I don't know any other. It's not PHP. This is Dart. Again. Okay? But why that version of Dart is a lot better? It's more than twice the amount of FPS, okay? So why that happens? I didn't write a better code, okay? So it's not, there are no writing optimization, best practice, and things like that. The only thing that changes is that, wait a second, where did I put it? I changed the code here, okay. So, as you can see here, I have that class that describes, I can maybe, okay, can you see it better? Maybe not, maybe like this, okay. So, as you can see there, it's just a class that describes my particle. There's a double for the mass, a vector2 for position and velocity, and then a double for force. And then here, what I'm doing, I have a function that is going to take every particle. I'm generating a list, okay, of particles. That particle amount is 3,000, as I said earlier, and then I'm going to just put them in a random location, and then there's that update particles function that is going to create two lists of double, which is their acceleration, and then update their position. Then I have that model, okay, which is kind of the same, but as you can see, the position and the velocity, it's not described as a vector2, but as two doubles, one for the x and one for the y, okay? So using that approach, and instead of creating a list, I'll show you again for a second. Where did I put? Here. Instead of two lists of double, I used a float 64 list, okay, for the acceleration. Just those two changes gives you 2.5 times the FPS, okay? Why this happens? Because in Dart, variables, data inside variables are boxed. Okay, boxing is a technique that is performed in low-level programming, and Dart also uses that technique. What is boxing? Boxing means that once you write int x equals 5, that 5 is going to be boxed, and then every time you want to modify that value, that variable needs to be dereferenced from memory, unboxed, updated, reboxed, and then you put back in memory. And that is an expensive thing. So what is actually happening here? Every time you have a complex type, like a class, so vector2 is a class, but as you know, also double is a class in Dart, okay? So why there's a difference? Dart is smart enough, not Dart, but people who wrote Dart were smart enough to let you use int, double, and few other types freely, and they are actually unboxed by default. Okay, so Dart is smart enough to, if you create a function that accepts two int, okay, they are not boxed because Dart knows that you are using them just as int. You are not using every other function that you can inherit it from the fact that int is a class, and so is unboxed by default. In every other case, the values are boxed, and so the flow that I explained earlier is performed in every second, and so the performance are totally slowed down. Okay, and nothing. I think I've explained everything. Yeah. I just want to thank again Marco for helping me. I don't know. He's here in the auditorium. I don't know where he's seated. I can see him. Okay, but he's here. Okay. And also, I want to thank Slava. He's a Dart VM maintainer. I reached him on Twitter, and he was so kind to reply me, and we also have a meet call. I talked to him, and he explained me a lot about how it works under the hood. And so thank you so much to those two guys. And these are my contacts, and feel free to text me. And if you have a question, ask me now or later in the hall. Thank you so much.
Thank you so much. Great talk.